Well, welcome to the 46th session of Dialogues, and it's going to have climate change as the topic, and specifically climate crisis. It's obvious that I'm not actually going to make a long-winded introduction on the matter. I think that everybody can understand why we're interested in this matter, and for what reason we must, whether we are here together or whether you're actually watching us online, to leave a bit the wiser and better informed about where we now stand in terms of the climate, how much we affect it, and mainly what is the margin that we have, what is the leeway we have from here on for our action. So, of course, it's not the first time that we are going to talk about this, because there's the Rosniarchos Foundation that actually, together with the non-profit organisation IMED, has launched already the subject matter of climate change. It goes without saying that this is a matter that will not actually be limited to our generation. Now, the question is, how many generations will in fact have to look into it? And beyond those who are here today, there are in fact those who view us online. We are in a historic venue. It's one of the most emblematic halls worldwide, I dare say. It is in fact the first research body of our country, of Greece that is, and I'd like to thank Professor Zerefos for granting us this hall for this event. And I'd like to say that it was a very good thing that you opened the doors of the Athens Academy and welcomed us all. Welcome all of you to the Athens Academy. So, Professor Zerefos is the Secretary General of the Academy of Athens and the Climate Envoy for Greece. And I'd like to welcome our other interlocutors, Niki Valpidou, Professor in the Faculty of Geology and Geoenvironment of the National Kapodistrian University of Athens. Welcome, and thank you also for being with us today. Thank you very much for the invitation. It is an honour to be here amongst such distinguished panellists. And Professor Zanis, welcome from Thessaloniki. I think that you just came a few hours ago just for this discussion. You're a professor in the Department of Meteorology and Climatology, School of Geology from the Aristotle University of Thessaloniki. Thank you for your presence. Thank you all, and this is a great honour for me to participate in such an interesting discussion. I hope also on my side to contribute in order to disseminate information on climate change, so we know what the physical basis is, at least. As you might know from those who are here present today and those who are watching us online, the dialogues are open to all. It is a public debate which takes place every month for almost 4 years now. The purpose being that we should all be engaged in it. We should all be able to address questions to those who are experts and who are from academia, and they're here present today, but also the speakers we have each time, express our views, any disagreements. This is part of dialogue, and we defend this warmly, so long as there's arguments, and that's where we focus on. That's the interesting point. In dialogues, we meet online, partially online, but also in person, because as you see here today, we have our panellists with us, but we also have 10 citizens. We actually called upon you, and thank you for responding and being here today with us. And I must say that we had an overwhelming response of the audience to participate in this discussion that's going to be launched. Of course, due to the conditions, because of the pandemic, the number had to be limited. Thus, we have the pleasure to have 10 people with us here today in order to engage in this discussion and to really open the floor and discuss it. Those of you who are watching online know that you have your own space and time in our discussion. So send us your questions, views, comments that you want to share with us in our email, in our site, through the snfdialogue.org questions, or in the social media. You can find us on Instagram or Facebook. SNF Dialogues is our account. And beyond those who are here today, and those of you who are watching online, we also have two very interesting interviews that we're going to watch. One is from Norway, and it is from Birgitte Njåstad, from the Antarctic Program Leader at the New Norwegian Polar Institute, and the second from Sasa Stasvik, who's the Senior Advocate for the Agency for the Planet, and she is from the United States of America. She's the Senior Advocate from Climate and Clean Energy Program. So there's no reason to actually explain why we have to launch the discussion about this matter. I can also talk personally, from the moment that I remember myself, from the moment that I was born, more or less, I've been hearing about green growth. And I now find myself at an age where my generation is being heavily criticised by the younger generations with respect to the problems we've caused the environment and the harm we've caused. I think this says a lot with respect to what's not been done and with respect to how much harm has been done. But we see that time goes on and we haven't managed to put a halt to it. So let's start by those of you who are with me today. So why are you with us here today? Why did you express your interest to participate in this discussion and dialogue? What are you interested in hearing from this discussion dialogues, and whether you feel that something's missing from public debate? There's a lot said with respect to climate change, and we have very catchy titles, and they've coined rather interesting phrases. But what is missing? What do you feel is missing from public debate? And what would you like to be heard today? If you could please wait for the mic and introduce yourself. My name is Kakis Nikos. I'm 23 years old. I'm a student of architecture. So this presence here today of mine has to do with my subject matter. I'm very interested in being engaged in this. I want to hear about the strategies that we can deploy in order to address the existing problems. And I think it's very important for us to be well informed. It's a matter of individual responsibility. I mean, it was presented that recycling would save the planet, but I don't think this is at all the case. So what is the root cause of the problem, and how can we actually tackle the problem at its root from the primary sector and so on and so forth, with various other systems coming into play? Please. My name is Konstantinos Stamboulis. I'm a student of Political Sciences and International Relations at the University of the Peloponnese, and I'm here today because I'm 21 years of age. I'm one more from Generation Z. I have actually undergone 3 crises: environmental, sanitary and economic. So, of course, in order to be an active citizen, I have to be very much interested in all these matters. And I think this is true for my peers. I want to hear 2 important things. We talk about Europe being climate neutral in the future on the basis of what we know from the past and the economic crisis that we know. Can this be a just transition as we expect and we like to believe? And I would like to hear the scientists and what they have to say on the matter. And the second, citizens, what have we learned? What can the scientists do in order to make the citizens aware of the real problem? The media's role is such that we hear a lot about this, but it's very important to know what the real problem is in order to tackle it. So I want the scientific community's view in order to go ahead. Now, before we actually hear others' views, I'd like to ask a first comment to Mr. Zani, Professor, and Mr. Velpidou, because we see that with respect to Mr. Kakaris and Mr. Stamoulis, the discussion that you just outlined is how we want things to unfold. We want to know where we're at, and we have the recent findings from the report that we're going to just see now, which was completed in August. And we want to see what are the findings from the past, and we want to see what we should do. What are the actions from now on in order not to simply pay lip service to the issue? So the role of the scientific community. Okay, the role of media has been discussed at length within the dialogues, that is. But let's look at the role of the scientists and how science can assist with interventions and do it here and now. But then we'd like to look at where we are at the moment. I'll actually get the ball rolling. So I think that these are three distinct issues, and we must look at them. One is scientific proof about whether climate is changing, and what is the proof we have with respect to this climate change that is being observed. And this is where the scientists come in order to give responses to the observed changes. The next goes a step further, and we look at the repercussions of the climate change and the adjustment that can be made in order to tackle it, to tackle this climate change in the future. And thirdly, and very important, how we can actually curb emissions. And I would like to actually refer to what was said in terms of individual responsibility. We have to go top down here, and I believe that's the case because climate change is a global issue, and it actually has to do with strategies deployed on a global level, and these will be, of course, adopted by the various states worldwide. Of course, individual responsibility is a very important thing, and it goes in the right direction. But if we don't actually have a good strategy top down, we will not be able to expect positive results. I could say many things here, but because I have participated in the report for the IPCC, the Intergovernmental Panel on Climate Change, that is, of the United Nations, I was very fortunate to be amongst the authors. We saw that 234 scientists participated from 60 plus countries, precisely so, and a panel which has very stringent criteria with respect to the report. In addition, it's trying not to conceal or hide any facts, but open them up. But it's not going through new research, or it doesn't carry out new research. It actually examines the results of the scientists worldwide. So if I'm saying it correctly, Mr. Zanis, this is issued every 6 to 7 years. Yes, the previous one was in 2013, and this is now in 2021. What's the new look that it's brought to the scientific community that we must all know? Now, what is new here is that with greater certainty we can ascertain that there is a change in the climate. There is a change in temperature, and by 90% it is in fact caused by greenhouse gas emissions and by man-made activities. This was in fact something new, because in the past they attributed a smaller amount to human activity. But what contributed to this is that we had 6 or 7 more years of observations. We had 5 years that were a lot warmer. As of 2016 onwards, we had some of the warmest years since we were able to use instruments, and we have new observations, and we have new generations of mathematical models that have more physical processes, and we could record these. So I would like to put a full stop here in order not to be long-winded and to give the floor to the other speakers. The IPCC wants to respond to 3 questions. The first is, what do we observe? The second is, how can we attribute, or to what can we attribute what we observe? And third, what are the forecasts we can make for the future? And solutions, but this is a matter of policy. But scientists can say, what is our leeway in terms of solutions? I think that's the most critical matter. And I think that during the discussions you will give us some very important dilemmas that you're called upon to address. And referring to the scientific community here, because we are at a very difficult crossroad. I'm saying it very simplistically now, but we're not actually having a discussion about whether we should do something, what is that, but how will we go about it? Because we don't have any margins in what we do. It's not only time which is coming to an end, but also our leeway. And now we are going to look at where we're at. Mr. Valpido will talk about the process, how things are developing in terms of climate and the temperature conditions, so we know what are the changes that brought about the crisis. Before we see this, however, Professor, Mr. Zelivosh, before we go there, we know that you're an assessor of the report that we're referring to, and which has given us, in fact, the key results, or that Mr. Zans has actually referred to just now. Another point which is worth looking at, as this is actually seen from the report, that even if we were to stop the emissions now, global warming will not end now, and it will last for at least 30 years or so.
Maybe 100 years. It depends on the type of gas and the mechanisms of the physics and chemistry of the atmosphere in the next decades. If I have 3 minutes, I would like to say the following. Before you gentlemen were born, in 1995, Professor Paul Kreutzer called me. I was a professor at the Aristotelian University of Thessaloniki. He is a Nobel laureate in chemistry. Back then, in 1995, and he called me at 11 o'clock in the night to say, Anthropokenos, Anthropocene, is it of Greek origin? And I said, yes, it comes from the Greek word anthropos, as in anthropology, and kenos, new, modern man. So this is what Kreutzer proposed. And as you know very well, many conferences were organized on this Anthropocene period. Why Anthropocene? Because this is a period which is something almost to neglect geologically, because it's 50 or 60 years, a 50, 60-year period. Let's say 50. But human emissions now compete with the emissions of nature. Till the beginning of the Industrial Revolution, that is, till the beginning of the previous century, we had the thermoregulating gas in atmosphere, which is CO2. We had 250 parts in 1 million. In 1 million molecules in the same volume, you could see 280 molecules of CO2. What does this gas do? It acts like a cover an invisible cover of the globe in order to regulate the atmosphere. That is, the temperature of Earth. It's not like the temperature of Mars. So it's plus 40.5. This is the average temperature, and you were born within this temperature. Your father, that is people of my age, and your grandfathers were born in a planet having other temperatures, especially the ones who were born in the beginning of the 20th century. What has happened in between? Why is it that now we see this increase in temperature? We have an increase of this basic gas that traps the thermal emissions of Earth to the space, and we are more now than 430 parts in 1 million, from 280 now. So if this is doubled, the temperature, the average temperature of our planet will go beyond 17 degrees Celsius. This is this overheating, the global warming, which depends on greenhouse effect gases. And those that deny are skeptic. Well, this is a philosophical term, and it's wrong for them to use it because it's not skepticism, it is just doubting science. So it's very interesting to know. Could you please tell us when this trend started, the trend of those that deny climate change? But I see that there is an interesting internet question. You can see it on your monitors, those of you who are online. I'm going to read it out. Mr. Zanis, could you please give us an answer? Which are the most polluting industries on the planet right now? Given that, and Madame Evelpido will tell us more, that the temperature of the planet is increasing, and we clearly see that this is happening at a very rapid rate because of man activities. Which are the most polluting industries? Which are the most polluting industrial sectors? Answer. I would like to say the following. The greatest sources of CO2 come from mineral, from fossils, I would say, fossil fuels. But then there are other gases, not just CO2, methane, for example. And as regards methane emissions, I would say that 60% of methane emissions come from human activities, and yet indeed 1/3 of them has to do with fossils, extractions and transport, animal husbandry, and also waste and agriculture, mainly rice production. Over and above methane, we also have, I would say, various substances that contain chlorine. We have these gases that are used as propelling gases because they are very volatile. Some of them have been reduced because they were also depleting the ozone layer. But even the new gases we use now have an impact on forcing the climate. I would say we have this type of term. This is a type of forcing the equilibrium in atmosphere to change, plus ozone, and also some natural causes such as vapors. I have to say that the time life differs. CO2 is 100 years. Methane only lives for 10 years. Methane is about 20 or 30 times more powerful. This means that it covers our planet in a better way. Just imagine, it's like using 20 or 30 planets. However, the other CO2 lives for 100 years, and hydrofluorocarbons or any type of chlorides live more. So now we have this type of substitute hydrofluorocarbons, for example. We have managed to use these new types of chemicals to protect our planet after the Montreal Protocol. And it's good for people to be informed. There is a need to do something about it. And I think that there are many relevant questions. Okay, now let's give the floor to Mrs. Evelpidou, who is going to explain where we stand now, because we all know, and we have heard our professors, Professor Zerefos and Professor Zanis, that there is this increase in climate temperature, ices melt, and we have this rise over the sea level. This has to do with heavy industry and human activities. Now, could you please give some examples of this procedure and where we stand now, when we are, in order to see the impact of intense human activities as regards the rise of the sea level? Answer. Okay, let's take it from the start. We have the global warming. This has been happening all through the years. We had some interim periods with ice, glaciers, and then some periods which were warmer. Now we are living in a warmer period. There would be an increase in temperature and glaciers would melt. But now man comes in, as mentioned by my colleagues before, and we speed up this procedure. This was a natural procedure, but we have accelerated this procedure. What will happen? What is expected now? I don't know whether you can see some maps on your screen. Could you please show us? Yes. What can we see here? Because it's a well-known map, but with unknown data. Look, here we see the Cyclades 18,000 years ago. So back then, rewarming was starting 120 meters below was the sea level. Why? Because it was cold. And a large volume of water was stored in glaciers. So we had this drop of 120 meters. What you see in green on the map is what was happening then, this huge island that used to exist back then. All these islands were only one island. So what we see in green now, it was dry land. It was dry land, it was an island. So you understand that people could walk from the island of Paros to Naxos, and they used this area for cultivation. Then there was this increase in temperature, and the sea level was coming higher. 14.5 thousand years ago, warming was very rapid. Initially, 7,000 years ago, the rise of the sea level was very fast because the melting of the glaciers was fast too. You can see now that the islands are separated. Some of them are still united, for example, Paros and Naxos, and small Cyclades. 13,000 years ago, 60 meters below in comparison to today. So you see this was lower than today. Just imagine human beings back then. Human constructions were there close to the coastline. All these constructions were flooded. So we see many constructions in the Mediterranean or many ancient ruins below sea in the Mediterranean. And this was happening very fast. People would experience this change very fast. 12.5 thousand years ago, and this is the situation today. What was happening then is what will happen now to us, because the sea level is rising fast. These 120 meters I told you before of sea level were increased within the first 6,000 to 7,000 years. Then things stayed the same. The rate of rising was very, very small. The generations before us couldn't even observe it. But today we have a very, very rapid increase in temperature because of our activities. This leads to a very rapid detachment of the covering of the glaciers. We have an increase of the rise of the sea level. So in prehistoric times, prehistoric men could see floods, and this is what we are going to experience. Where the areas that are coastal areas and level areas with low relief. And here we also have some socioeconomic issues, because in these regions we see more activities. So it's local administration, local government. We will come back to this in our second example. Greece is actually a case study, I could say, because we have large coastal areas in the islands and in continental Greece. We have forests, which is another topic. We are in the Mediterranean Sea, which is in the epicenter of the climate change. In the future, we will see it more intensely, and then we will see what nature causes. We see some natural phenomena which, however, are accelerated by man, and we see what nature has to do to protect itself, and it is human beings that destroy the natural protection. I have to stop here, and I will give the floor to you. What do you think about all these?
Well, good evening. And I am a PhD candidate in the statistics department at the Athens University of Economics. I wanted to put a simple question. As you say, that instead of noticing this change that you described before, in 2,000 years from now, we're going to observe it in how many years? Is it going to come to pass in 50 years or sooner? That is exactly the case, but it's not in 2,000 years, it's in the next 10,000 years. The scale is 100-fold. What happens in hundreds of years is happening as everything becomes bigger, because we have a greater rate of the ice melting. So the average temperature of the sea might have been increased in the Mediterranean by almost 1 degree or 1.5 degrees. But if you go to the Arctic and Antarctic, more to the Arctic rather than the Antarctic, it's increased by 3 degrees. So if we continue like that, the entire ice cover will be lost in the Arctic, with a huge expediting of the climate change, the so-called Anthropocene that I mentioned before. That is where the danger lies. When you have a fever, what do your parents do? They actually feel you to see if your head is hot. And if, however, we feel the temperature of the Earth growing, well, that's bad news. We have a destabilization, which is happening very fast. We have a rising sea level, of course, and we see that the climate itself is being destabilized. And we see that the climate phenomena happen in order to be able to actually let off steam. And, you know, when a new typhoon is born, it's like a young child. It wants to give the energy, it wants to move, it wants to actually go forth. But in a destabilized climate, this child finds itself within a chaotic system. I mean, you talked about statistics, you study statistics, and you see that this is now chaotic. And this means that things go faster somewhere and slower elsewhere. So this chaotic system is not organized. And when it starts being organized, if the warming happens in a systematic manner, we will have, in fact, great disasters throughout the planet of biblical proportions. So I think, Mrs. Buzluko, ladies and gentlemen, what will prevail is actually the decarbonization. We will rid ourselves of fossil fuels and other greenhouse gas emissions, because those that are curbing their use are those who sell them. So these are the major oil companies, the ones that have fossil fuels, those that use them or transport them, the ships, the vehicles. When they get to grips with the fact that they can do the exact same job, they can have the same number of jobs and earn the same amount of money, there'll be not even one denier. We saw this with the Montreal Protocol. I had the honor to be there from the outset, from the Ozone Trends panel. That's what it was called. So this created the Montreal Protocol. The 13 chemical industries, who are truly giants in the world, could not be convinced that they could substitute the gases that actually depleted the ozone layer without a huge cost. But when we told them that it's simple, that there are substitutes, and then we will actually make the consumers to foot the bill, they accepted it immediately. We signed in 1987 the Protocol of Montreal, and then we had the Kyoto Protocol. So the Montreal Protocol was signed by 37 and the Kyoto Protocol by 33. Now the Montreal Protocol has been signed by all countries. So certain islands, I mean, that are very remote have even signed it. But when it comes to the IPCC decisions and the Paris Agreement, these have not been signed by everybody. And the remote islands actually sign them because they are sunken already. So I'm sorry to interrupt, but beyond signing a document, what happens in practice? And we come back to what you said in the beginning, and this is a question to be addressed to all of you. I would like, with one or two words, all three of you to answer. What do you respond to those who deny, who refute climate change and talk about conspiracies? I mean, who should conspire in order to increase CO2 levels? It's measured by all. We all know how its values rise and how methane is on the rise and how NO is increasing, nitrogen oxide is increasing. So we know how this is impacting on the average temperature of the planet, and it's already gone up 1.1 degrees centigrade worldwide. I would like to ask them to look at the graphs. They speak for themselves. How the temperature rose in recent years and what is happening now, and what happened in the past. So this brings me to something else that I was going to put a bit later on. We found this diagram, this chart on the internet, and I'd like you, Professor, to comment on it, and then Professor Sands, I'll come to you. I know that you've been waiting, but we found from the United States Environmental Protection Agency this graph, and it shows in 1930, compared to all previous and subsequent years, in the US, temperatures rose to unprecedented levels. Response. This does not show temperatures. The temperature diagrams over time shows how much it's actually destabilized after 1970. This is an indicator, which is a statistical trick, and I could actually create 100 indicators to show that the planet is getting warmer or cooler. But the indicator that we all know is our temperature. This is the indicator we take when we get ill, when we fall ill. And we know without a shadow of a doubt that the temperature of planet Earth is increasing. And we know that the possibility of, in fact, a heat wave actually occurring in 45 states of the US. And at that time, perhaps they hadn't even talked about what a heat wave meant. I mean, it is the Global Meteorological Organization that defines what the heat wave is. But it is, in fact, an agency. Well, if this agency has created this indicator, then very soon it should explain why it did so, because it doesn't depict how things stand, because the incontrovertible fact is the temperature. The easiest thing to actually measure our fever and the destabilization of the climate is, in fact, our temperature. You see that the temperature is on the rise since 1970. And if you look at the heat waves, I'd like to actually give you an example. So, in our country, we hadn't seen a major heat wave since 1860 up to 1875. Then the next, in 1887, then the next in 2007, and another one recently. Okay, we've been talking about it quite a bit, not you and I, but generally we say, okay, oh, what a hot summer, and what a heat wave, and there has never been a summer like it. What has never been seen before? So I will keep that for afterwards, and we can hear you now.
My name is Petros Apostolakis, and I study economics at the University of Athens, and I am a climate activist. I organized the march on Friday for climate change, and one of the main issues we raised is that we do not have solutions, but those that take decisions have to listen to you, the scientists. The most difficult thing we have to deal with people of our age or older is to practically show them what climate change means for their daily lives. That is, how would the life of a Greek person in Athens will be 50 years down the road. And I think that this is the only way to raise public awareness, because then people practically see that their lives won't stay the same. Thank you. Thank you. I think you wanted to take the floor. Hello? My name is Komi Apostolia. I'm a geologist, and I would like us to dwell on the issue of the rise of the sea level. I would like to ask the following. Is it possible in the future to have the same scale of rising all over the world? And are there any methods to record changes worldwide or even forecast changes at some points on the globe? Let's keep this question. We'll come back to this later. will focus on the rise in sea level, and Mrs. Velpidou is going to tell us more on this. Let me come back to Mr. Zanis. Since the temperature of the planet was to rise anyway, how can we measure man activities, the impact of man activities? Because you see that we all need examples, regardless of our backgrounds. We need to understand, because we want to comprehend what we said before, that this was a strange summer. For example, in Canada, temperature went almost to 50 degrees Celsius. Here there was no rain. We had heat waves coming one after the other. So what is worrying, if it is worrying, but I am just talking about the facts now, and could you please give us examples, is that there was a heat wave up to 50 degrees. Is it worrying that there are more frequent heat waves now? Mrs. Bozdoku, these are too many questions. It's not just one. Yes, but they are all linked to this increase in temperature. And you know, there is a great debate focusing either on when was the first time we had such a heat wave, or whether this is going to be our daily bread. I think that it was in Naftemboriki newspaper, it was a report for the next generations, and according to this report, there will be extreme weather events like heat waves. Look, from the meteorological service, we know that in the 80s there was one heat wave with a duration of at least 8 days. Next decade, 2. Next decade, 3. And in the last decade, 4. What do you mean by heat wave? How many degrees? Has the definition changed? Proportionally always, depending on the geographical position. We have the same type of analysis. Of course, there are different ways of defining a heat wave. But anyway, let's say that the temperature here has to be more than 35 degrees Celsius for 4 or 5 or 6, 7, 8 days. I think it was 8 or 9 days this summer. But anyway, there are various indicators, and you can compare them. The results are similar. What we have to say is that, yes, there is this trend in the last 40 years of having an increase in these events. Only half a degree of increase now. Let's say that we have 1 degree in comparison to the pre-industrial era. When we go to 1.5 in the next decade, we could expect 5 such events. What is frequently debated is also that this heat wave because of human activities. And we all know that nature is more powerful than man. And nature has its natural ways of changing in order to create the weather. Weather is something ever-changing. So we cannot say that just one event is caused by man. What we usually examine is the statistic distribution of similar events also in the future. Because the atmosphere, or rather, let's say that man activities are just a substratum. This is a very simplistic example I use for my students to explain to them what are these human activities. Let's say that I am 2 meters tall and I want to go through a door which is 2 meters tall. And I can do it without wearing shoes, however. But if I put shoes on, which could have a heel of 2 centimeters, I have to stoop, otherwise I will hit my head. So, of course, natural changes are huge in comparison to human activities, but things are not linear and not static. So disturbances could be caused at some points of the planet, and this extra additional energy, because now we're talking about additional energy, could find a way out in certain sites where we could have more extreme events. So human activities are not that important in comparison with the power of nature, but these small activities can be enough to cause disturbance. Now, from where Mr. Zanis stopped, Professor, could you please take it from here? And you know, we are reading that Eastern Mediterranean is at the epicenter, or will be one of it will be the focus of extreme climate changes. On the basis of the evidence we have today, could you please explain what could we expect as to the changes of the daily lives of the average Greek or the average citizen of Athens? Of course, we're already experiencing this period. In my time, there was no urban heat islet. For example, Athens, Thessaloniki, Patras, Larissa. We have this disproportionate increase in temperature because there is too much concrete in our cities, and we feel the heat even stronger. But if you compare the temperature increase here with the increase in the Kelia or in an area which is not an urban area outside the Attica basin or far away from the greater Thessaloniki area, we will see that in the day of the heat wave, everything becomes very warm. But in Siberia, last summer, the temperature was 38, as in Athens. Athens and Irkutsk had the same temperature. An American would say, "Come on, what are you talking now?" Or Canada, Mr. Zanis mentioned the temperature in Canada, 49. So we have this extended reduction in average humidity on the ground, which could actually set vast forests in fire. In Siberia, it's not wildfires in California or in the Amazon region. In these cases, we also have this reduction in humidity because these are the rainforests, and you know, and they create their own humidity. So if we cut the forest down, we also see this phenomenon. We have this forest cutting down for other uses, for exploitation. So we have this destruction in the balance of the ecosystem. In the Eastern Mediterranean, we're one of the 10 points that are called hot spots on the planet. We have frequent floods, and this is a question we have received. So we see frequent floodings. Are these floodings linked with climate change, or do they come as a result of human activities? Well, it's complicated. We have two things. We have these illegal building, wild building everywhere, plus climate change. These two things coincide, and we have a disaster. The case of Mandra, for example. The floods or the torrential flood in Chalkis last year. Nobody could imagine these things in the past, because actually we had this disaster was a combination of many things. The flow of water was not left unobstructed. Nobody can stop water, as we all know. even humidity at home, we need to do special processing to avoid it. So water is something that follows the Newton laws of gravity and will go on its course. If we try to stop water, there is a theorem there. If you create a bottleneck, water and wind will go through at an increased speed. So we have the destabilization of climate, and these phenomena become more extreme than the average phenomenon of the past, and at the same time human beings change the topography of their regions for financial reasons. So this phenomenon and this activity is not frightening, but it's this human intervention which actually accelerates things and intensifies the phenomena. Yes, but the basic reason why we see, for example, these phenomena more frequently, okay, these we have two. We have these storms, we have torrential rains, too much water comes down, and if there is no catchment area for water, it's like having too much water pouring in your sink, and the water cannot come down the sink. Well, I'll come back to what Mr. Zerefos said. Let's have a look at what happened last August in Siberia. Flooding in August. You see a photo here from the region of Politica. The region where the flood was. Traditionally, there were always floods there, not just in Politica, in this area. So there were always floodings there. So this is how the lower level grounds are created. This is the natural way. So these are the floods that bring in material, but then we have human beings that try to do something. You see the limits, and you see the water, and it was mud. It was not just water, it was water plus mud, 1.8 meters. This was how high it was. And you all realize what this means. Within 8 hours, we almost had 30 millimeters of rainfall, 300 millimeters, and in 1999 we only had 150 millimeters of rainfall, and there was another flooding. So, as Mr. Zerefos said, very quickly, in a very limited period of time, we have many millimeters of rain, we have human interventions and wildfires in the hydrographic basin through which the water had to go. Well, we had a wildfire. This means that there was nothing stopping the water. Anyway, the rainfall was torrential, but there was nothing to put a stop to the water. There was no way for the water to sink in, which would be good in order to avoid desertification. So we had the water moving on the surface downwards to the sea, and you know the coastal areas are inhabited, and there was nothing to stop the material. So water with mud and stones came down, which only caused many problems to the urban fabric. And this material was lost, this mud, this soil. This soil was up there on the mountains. It was there on the mountains, and this would help the trees to grow again. But now there is no soil, so we have this vicious circle. Now we have lost the soil. It's very difficult to achieve vegetation again, which means more surface moving of the water downwards, no soil to cultivate, and we won't have enough time to gain water underground to avoid desertification. Mrs. Evelpidou, what can you say about this summer? We had the wildfires in Evia and in Attica. What happened in Evia in 2020? You have to multiply this. If there is a torrential rainfall, as in 2020, so actually we have to ask for less rain. If we don't have this type of rains, if we have extreme rainfalls, there will be floods. We will lose the soil left. There is going to we are going to have mud, landslides, and we know the regions that are mostly at risk. They will suffer. They will be destroyed. There will be floods. And the same goes for Athens to a larger extent, because the relief is not that intense. You know that if we had this intense relief, it's easier for the water to move downwards. If the relief is smoother, we have some time delay, something we want, because this gives time to water to go down the soil and become part of underground waters, and then there is a delay. It doesn't reach the urban areas, and we have some time to react.
No. So if you can answer very fast, yes. Yes, Attica might have, in fact, a smooth way of percolating the water, but its incline is very sharp. It's like my hand is. So that means that there's a great difference in altitude from Kifisia to Faliero. So I think this is very much of interest for our architect here. When Le Corbusier made his first visit to Paris and he was going towards Athens, he said that Attica is like a shell, and in the middle of this is the pearl, which is the Parthenon, and that it finds itself on an incline. So the incline is, in fact, very large, and it actually takes thousands of tons of water towards the water in a very fast way. The first who spoke about this phenomenon, and this might appear to be paradoxical, was Plato in Timaeus, and he talked about the deforestation of Mythos in order to build the so-called wooden walls, actually the ships that would fight in the naval battle of Salamis. And that, of course, created, in fact, the inability of the Earth to retain the water. It's very interesting to look at this, because we saw that the way that he explained that the entire slope of Mythos was transformed into an area that made exceptional honey because it lacked forests, trees. I want to talk about extreme rainfall. If we look at the IPCC report and from previous reports, if we were to classify the vulnerability of the Mediterranean with respect to various procedures, I would say that the heatwave incidents are things that we've actually experienced and seen, but can also be reflected in the forecasts. They say that they're going to increase, and there's a great certainty attached to this forecast. Now, the greater part of desertification, especially with respect to Mediterranean, has to do with the following. Besides the increase of the temperature, there's also a trend to have reduced rainfall in the future. this will be more obvious post-2050 with respect to climate simulation, that is. So this combination, as Mrs. Zerefos said before, makes the Mediterranean into a hotspot of climate change. So is it the heat waves that are going to actually concern us? These are the ones that we can be certain will increase. But the combination with reduced rainfall gives us, in fact, a greater possibility or likelihood of desertification. So it's not simply the climate which is a stressor for the whole issue of desertification, but it's also land usage and how we go about using the land. Now, when it comes to extreme rainfalls, we don't have, in fact, robust proof that this is going to, in fact, increase in the year to come. At least in the climate models and from the observations, there are no specific statistically exploitable trends with respect to these rather large rainfalls. And we see that rainfalls is, in fact, a field that lacks homogeneity, and I think that we are going to be very much preoccupied with heat waves and desertification in the 21st century. So let me actually talk about land usage. But before you do that, can we actually listen to our audience? They're here to discuss with you, so we're all ears. My name is Aral Viki. I have created an NGO, Mortality, which has to do with ethical fashion and volunteerism. And I would like to take perhaps a different perspective, and I won't combine climate change with the change of climate and the Eastern Mediterranean. And I'd like to talk about a hesitation that I have with you in order to find an answer to the question that I want to put. So we see that green and smart urbanization and the ethical fashion that I serve and other actions that take place on a global level could help us stabilize perhaps the climate in order to do away with the child labor and social inequalities. At the same time, we see that there is in fact a great need for cheap energy, for cheap food and cheap living costs. And this goes in fact contrary to this struggle for climate change. So I'd like to ask you, as you are in fact very much abreast of all these developments, if there is a position that relates to a sustainable solution, and how realistic is that? I'll keep your question for the last part, the third part. As I said in the beginning, immediately afterwards we're going to talk about what can be done. So we're all very interested in this. It's my son who's very interested in the answer. We're all awaiting the answer, but so we have to look at the facts first. I'd like to ask the following. From what I've understood, we will see in the future, in the near future, an exacerbation of the phenomena that we already observe. Perhaps with this change in the currents in the sea and in the atmosphere, we might actually have, in fact, changes in the geographical position of certain phenomena. What do I mean by this? Is it possible that we will see, in fact, typhoons in Europe? Is it likely to have hurricanes in Europe? Well, hurricanes in Europe, no, but extreme storms, yes. The creation of hurricanes has to do with the rotation of the Earth, especially in the tropics. And it needs quite a bit of sea in order to be able to actually keep the impetus of this large volume of air together with vapors. And this is something that we don't have in most of the continents, but is only found close to the equator. So what can be certain is that the frequency of occurrence of such extreme phenomena, whether these are heat waves or a lot of rain or drought, which is the reverse. Well, I'm certain that these are things that we're going to come across more and more frequently. So my name is Said Zianis, and I'm a geologist, and I'm a PhD candidate in the University of Athens. You talked about geophysical phenomena such as forest fires and floods. And I'd like to focus on Greece. Which other geophysical phenomena are we expecting in Greece, which would be the result of climate change, but also the situation that we now found ourselves in? Thank you. Well, thunder and lightning. And you know, Greeks don't know lightning. We forgot about it because we don't actually read what they wrote. So it is, in fact, a very big phenomenon. And we see that its incidence is, in fact, increasing in recent years. And it's a very bad thing because we see that thunder is, in fact, the result of the high charges, which are very high up in the atmosphere and the ionosphere, because it becomes a condenser. I don't know if you understand what I'm getting at. It's like a battery, which has two poles, plus and minus. So we see that we have the minus, which is the planet, and we have the other charges on the ionosphere, and they actually discharge when it's possible. So that is a storm. Thunder comes, and the charges come down, and we charge the condenser. The condenser has to be in electrical equilibrium. What we heard Franklin say in the 1780. So we have to see whether climate change will continue to discharge in an unusual manner. That means to actually really alter the electrical charge of the condenser. So it is, in fact, something that will really disrupt the atmosphere. If this is disrupted, we'll have very big changes in how the ionosphere actually discharges on Earth. And there are thunderbolts. So we have victims who have not actually people who people don't realize that when we're swimming, our head is in fact the highest point on the horizon, and it is very attractive to thunder, and you can be struck by thunder very easily. That's very interesting, Professor. And now I think that you wanted to actually note something before. Now, in a comment that my colleagues made before, that the change in terms of the land usages might well result in a greater risk of floods. I want to give you a very simple example that illustrates the point. Now, those of you who have actually gone to the islands of Greece, and especially those that have in fact large inclines, you'll have seen terraces. We have characteristic terraces. It is a very known landscape in Greece. So why did they create the terraces? This was the way in a steep landscape for people to have level areas in order to cultivate crops. So it's as simple as that. But what did this do? When they created these terraces, when there was a lot of rainfall, the rain did not actually go that fast to the lower levels, and because it had all these terraces that delayed it with the plants that it had, and the land uses changed. How so? So most of our islands became very touristic. People had no reason to cultivate such a difficult and steep landscape in order to recreate the terraces, and started being employed in tourism. So we see that the terraces are being set aside, they're destroyed, and we see that this also increases floods downstream. which means that the aquifer is actually not being replenished so much, and we lose a lot of the water into the sea, and they can no longer actually regain that land because it's actually gone into the sea. I wanted to put another question, and I would like to say a bit later on we'll see how tourism, which is developed in the islands, actually creates problems in the coastline and the beaches, as well as at the bottom of the sea. The question that comes, I don't know if Mr. Gilbert wants to answer, in the insular areas of Greece, the reduced rainfall is in fact very intense. So it seems that the water is scarce, and we have in fact a greater need, and people are drilling for water more and more. How will this affect the islands? Well, they struck at the very heart of the problems that we have in the islands of Greece. Truth be told, we see that drilling holes or wells is in fact a very temporary solution, because we're actually slowly drawing seawater, which destroys the aquifer, and that also makes all the terrain saltier and less capable of bearing crops. And we see that this area has more needs because it no longer has the people it had, but many more, and it has to cover the needs during the summer months. And the cherry on the cake is the use of water for swimming pools. Even though we have the sea at our feet, we need to have the swimming pools that use, in fact, fresh water. So it is up to us to help find the solution. We can change the way that we operate. We can, in fact, help advance things in the right direction. We shouldn't expect everything from the decision makers. Each and every one of us can do something. What can that be? Everything that we mentioned before. We can go to the local government level. We need the terraces. So besides the fact that this is, in fact, a cultural element of Greek landscapes, it will also help retain the land and stop flooding. Also, we see a lot of swimming pools. I like swimming pools, but we have too many swimming pools and not enough fresh water. There are islands at the moment that do not have, in fact, fresh water, that cannot meet the needs for the summer, and know at a certain point in time the tap will have no running water. What can we do?
Could I tell what Aristotle proposed? He said, just take a jar, a clay jar, and put it in the sea for some time. And the water that will go through the pores of the material of the jar will be potable and beneficial for health. This is osmosis. Desalination. 2. The reason why we are how we are is the lack of organization in islands and coastal Greece. We are in sea and we say we don't have enough water. So I think that this doesn't have to get signatures from all over the planet to do something locally. No, you're right. Because, okay, you talked about signatures, because all decision makers have to sit down, listen to what scientists have to say, and avoid what happened last year with the United States. They sat in, then they left, then they will come back. But now, even on the local level, there are responsibilities. Yes, huge responsibilities, and I suppose huge interests. Okay, please allow me. Let's go to Antarctica. Because usually when we talk about ice melting, we talk about the Arctic. Let's talk about Antarctic now. This is why we talked to the Antarctic program leader at the Norwegian Polar Institute, Birgit Njose, who explained the situation as is.
Ms. Birgit Njose, thank you very much for taking the time for this interview. I know that you have been working for more than 26 years at the Norwegian Polar Institute, and I guess you've been a lot to the Antarctic. Which areas of the Antarctic is climate change affecting mostly?
I would say if you look at Antarctica, you can look at, there's an eastern part and there's a western part. And the western part certainly is the area where you will see sea changes more visibly than the eastern part. And I'll come back to the fact that the eastern part is also changing, of course. But West Antarctica, we have seen a very large rise in temperature over the 50 last years. And in addition, the ocean is warming around in the area. So there we see that, the ecosystem is changing. The ice and snow is disappearing. There's more ice-free areas appearing, more vegetation coming. And we see that some species are changing their habitats and the size of the population and so on. East Antarctica is also changing in the sense that slowly both ocean temperatures and changes in air temperatures in the combination affect the ice and therefore more the physical geography rather than the life that we often talk about when we talk about the changes.
The impact of climate change in the Arctic, I have a feeling that is discussed more often in the media than climate change in the Antarctic. Why is that?
Yeah, that's interesting. I think you're right. Coming from an Arctic country myself, we hear much more about the changes in the Arctic. I think the main reasons probably are, number one, that the very quick and rapid changes in the climate there have a very much more visible impact, I guess, in the sense of seeing that the sea ice is disappearing. You see that there are changes in the biota and so on. And not the least, there are people who live in the Arctic who can talk about the changes that they're observing. And again, I'll just have to stress that that doesn't mean that changes aren't happening in the Antarctic. And I think there are many reasons to be quite aware of what's going on. And if I may, I'd like to point to three areas of change in the Antarctic that we should be at least vigilant about. One is, of course, that the Antarctic is quite key in driving the global climate system. So any small changes in the ocean or the atmosphere or combination of that in the Antarctic can have rippling effects into the full climate system of the world and where we live. Secondly, of course, there's a lot of ice in Antarctica, as we know, and if that ice or some of that ice melts, we will have sea level change, and we know that's happening. It's happening faster, and that's going to be a challenge for low-lying societies around the world, of course. And the third is the ecosystems or the marine systems around Antarctica, which are also slowly changing due to these changes in the physical surroundings. And the biological system of and the marine environment around Antarctica also has influence on the full global marine system and the ecosystem services of the oceans in the entire world. So those are big questions, but I think those are quite key to keep in mind, even if we don't talk so much about Antarctica. That is quite key to remind ourselves about.
What do your teams study in the Antarctic, and what are your research interests there?
Maybe I would point to two directions that our institute is particularly interested in. And one is we want to contribute to fill the knowledge gaps of how the Antarctic climate system affects the global climate system. And for us, it's especially important to look at the interaction between the ocean and the ice shelves and how that changes with changing temperatures and how that again affects the system. Also the ice sheet across Antarctica, how that changes in the dynamics of that, because that has to do with ice reaching the sea and then sea level rise. And then we also look at past climate. To understand past climate is actually to understand future climate. So those are key in understanding climate processes. And then another track that is of interest to us is to study exactly the processes and the changing processes due to climate change in the ecosystems surrounding the Antarctic continent in the marine system.
Many believe that global warming is causing a very slow and steady melting of the ice sheets, as you said before. Is this the case, or should we expect more abrupt changes in the future?
Yeah, that's $1 million question, I think. At this stage, we're slowly seeing that changes are happening in Antarctica. Warmer ocean water are intruding in under the ice shelf surrounding Antarctica and melting them from underneath, I guess. And then they break up, and then the ice sheet on the continent starts to flow out quicker than before. And in particular, in West Antarctica, as we talked about. This is, at this stage, a slow process, although it's happening quicker than before. But there are so many knowledge gaps. And what we are concerned about is that we are reaching a point where you get to a trigger point where you sort of lose control of the ice shelves around the continent, and they all, or many of them, break up, and you sort of get a rush of ice coming out. This is maybe a too dramatic picture, but more than before. And if you get that trigger point and this starts to evolve, then things will go quicker and quicker.
Thank you very, very much for this interview.
Λοιπόν, ήταν η Brigitte Niosa, επικεφαλής.
So this was Brigitte Niosa, leader at the Norwegian Polar Institute, and this is what she had to say to Thanasis Tromboukis. At this point, with all pieces of information so far, I would like us to get to the great question of how to adjust to the new reality. And let's see what we could do in practice. Mrs. Evelpidou, let's start with you, because after what we've heard about the sea level, how can we see concretely how to adjust to the new reality and at the same time protect what needs to be protected and protect ourselves from what you described so far? Let me come back to a phrase in the interview. She said that we are studying the past to be able to understand the future. I think that we have to understand nature. We have to read nature. Let me show you some photographs. They are telling. Let's see. Here. What can we see here? It is a region that has many features that make it run the risk of coming from sea level change. It is a very low area. It will be fully covered by water. Now, let's have a look at this area. Now you see this red line and you see something that it is sunk. What is it? It is an ancient seashore. Here, this was the seashore, which 1,500 years ago was where I indicated before. It was here, and it was fossilized. In the same area, we see some other sunk lines, 3 meters, which is 3,000 years or 5,000 years ago. So we see some sunk ancient seashores. These ancient seashores here, when we go there in a very windy day with many waves, you see that there is no erosion despite the waves, sand, a nice lagoon. So the environment is vulnerable to erosion and the change of sea level, but at the same time it is very well protected. Why? Because there are these ancient seashores which are sunk and fossilized, and the waves consume their energies there, and they reach the seashore of today with reduced wave energy, and nothing happens. So we shouldn't destroy it. Yes, exactly. At the same time, a similar area, again you see these ancient zones, and we see what is happening today, and this environment is very vulnerable because of the possible increase of the sea level. You see the same phenomenon here. So you see that nature can protect itself. It's usually we humans that we don't like the rocks, for example, and it's not easy for us to enter the sea, and it's not convenient. We take the rocks out, we take them out. Why? Because we don't know, and this has to do with education and training. So we remove these rocky elements. We did this in southern Attica, and the whole shore disappeared within 10 years. And since I mentioned about sand and sand hills, something we shouldn't do, we all know the human activities in very vulnerable environments such as sand dunes, and of course we see some cars racing there, and there were some films that unfortunately were broadcasted. Anyway, sometimes the local authorities say okay, and things happen there, and we level the area in order to put chairs or anything. So here you see the topographic section, you see A and B. This is the topographical section along AB. Here you see where the sea is, here. This is 0. We have the sand dunes, roads in between, and this is this wetland. What's the height of the wetland? It's lower than sea level, but it is protected. It is protected by the sand dunes. So, maybe because we don't know, we destroy the sand dunes. After they are destroyed, the water will go back there. Yes, indeed. I think that things are more comprehensible now, and indeed it has become very obvious. Mrs. Evianidou, Professor, what do you think? How can we be realistic as regards adjustment on the individual level? We also have this individual responsibility, like buzzwords, but how can we be realistic as regards individual responsibilities and activities vis-à-vis interests you touched upon, lack of education, and that touched upon by Mrs. Evelpido, And if there is no agreement, if we cannot agree on how to deal with these issues, it seems that there is no agreement among world leaders. Answer. Financially speaking, the cost of climate change in our country, if we do nothing, this is the report of the Bank of Greece in 2011, so the cost could be 700 billion euro. Only for Greece, yes. 2 times our foreign debt. But if we adjust, the cost will become half. Adjust. What does it mean? For sociologists, well, they say that this is a maladjusted person, so we have to adjust. Otherwise, being maladjusted shall lead to the following. Let me give you an example. Let's say that there were no adjustments to the prohibition of these elements that destroy the ozone, and there was no Montreal Protocol prohibiting them. Today, everybody would have to work at night to avoid the sun and sleep in the morning. I have to say this in order to indicate how important these activities are. Therefore, if mankind did nothing, we would be working now and not in this nice show. Adjustment. To adjust means that I follow certain rules to create land improving projects in order to reduce climate change. We have to adjust means that we have to use natural resources less, like water saving, for example. Also energy saving, because energy is costly. Energy from the sun or from fossil fuels, yes, we can save energy. Our country is rich in alternative energy sources. Of course, this has to be further discussed, yes, but there is sun, there is wind, powerful wind in the Aegean, like the sun. As I used to say that we have 2 suns in our country, and geothermy. In some cases, especially in the Cyclades, on the islands of Milos, Santorini, Nisyros, we had this Yali too, the volcano was there, and there is geothermal energy to be used in some islands, even to desalinate water. This is why I said that adjustment includes a series of actions which will lead to enough profit. I wanted to say that Mahatma Gandhi said that Earth can offer food for everybody, but our Earth cannot satisfy everybody. So here we have a unique chance to offer food and satisfaction to everybody. Why? Because new energy forms and the new cities of the future will have less pollution, less noise. It will be easier for cars to move around, and noise will be almost zero. So we have a question from a very young student. What should children do to reduce the impact of climate change, and how important this assistance could be? Maria Ines Vambuku. I have set up an environmental club with my friends, and I would like to know what I should recommend to my friends. Could we just give some bullet points for this very, very young generation? Because these people want to communicate, they don't want only to hear. Look, Initially, I mentioned this topic. Indeed, individual responsibility and environmental awareness. How? Let's say that you had these junior high school students. Could you give them some examples? Simple examples. I turn the lights off when leaving home. I turn the TV off if not watching. No overconsumption of water. Recycling. Respecting nature. All these issues can be addressed by everybody. Of course, this comes from education. It's not something transferred to us. If I remember what was happening 20 or 30 years ago as regards the environmental issues, many people would laugh when somebody would say, "Do not smoke in a room." This was considered to be, well, yes, this is pollution. It's not climate change, but still it is respect for others and the quality of air. So I see that gradually we are building up an environmental consciousness. I am more optimistic. In the 80s, I did some research at the University of Thessaloniki, and only 4 or 5% believed that environment had to be protected. So this was lack of proper communication coming from the scientific community and then the media. Now I would like to give the floor to Mrs. Raleigh, because this example she touched upon through her questions and activities, because we have organized dialogues on this about fashion industry and environment. We focused on this issue. So this has to do with how we consume, how we behave as consumers, and this is not only limited whether we use plastic or paper straws. Of course, this is important too, but this has to do with the whole consumption chain and consumption behaviors. So could you please repeat your question and tell us a few things about your area?
Oh, because of I love fashion, I actually created this NGO when I realized how much fashion pollutes. I mean, it's after aviation perhaps, but when you don't know something, you are not responsible perhaps. But once you know that, you're responsible. So I think we have to do it with shopping therapy. Shopping therapy doesn't actually help anybody. We have to have informational campaigns from school age in order to perceive what it means to buy, in fact, a top that costs X euros, which we sometimes wear only 9 times. And sometimes we don't even wear something at all, because 30% of the clothes that we buy, we don't actually wear at all. And this fact that I'm going out to a shop to buy something will have a very serious footprint on the planet. And I think we should also look at the labour ramifications. So we're talking now about the supermarket consumption, if you like, the supermarket-like consumption in fashion. And this is very attractive from a financial point of view, but it is very short-lived, and there is lasting harm, and it cannot really help take fashion forward. So it's different to actually create a tailor-made item of clothing with good materials, which I'll wear time and again, and which I will either gift or return for raw materials. So it will not need to be burnt, as a lot of the clothes that we see in fast fashion ending up and being burnt. So we see that we should wonder why 99 out of 100 items are not recycled, and where do they end up? And we have to see the replacement of the linear economy. Linear recycling, that is, I buy, I consume, and I take it for recycling, and I actually dispose of it. With the circular economy, I should buy something a bit more expensively, and then because it's quality free, I can actually use it, and then I gift it on, or I use it for raw material, and that's a great saving on the raw material for our planet. Now, when it comes to adjustment, Professor, we have seen that the time is now, and we have, in fact, the Green Deal. It is, in fact, very ambitious goals with adjustments to the economy, farming and transportation. On this basis, are you satisfied by the ability to adjust in Europe? Let's not look elsewhere to other continents, at least today. And do you believe that these targets are realistic or perhaps overly ambitious to be reached? What a good question. When it comes to the temperature, I'm very worried. I'm very much afraid that we won't actually exceed 2 degrees centigrade. The Green Deal asks for 1.5 until 2050. And then we have targets for 2040. So you see, there were trials and tribulations in this respect. We're still really looking at what would be best. When we want to stabilize an extreme non-linear system is a very difficult thing to forecast. Now, what is optimistic in the Green Deal is that it awakens us. It gives us new horizons. So those who want to earn money will continue to do so. And nobody forbids it. Those who want to protect the environment at any cost are also encouraged to do so. And this could bring us to a better future. Will we be able to actually make certain that what is extreme is not habitual? If we have a day-to-day life full of extreme events, well, I'm afraid we will lose out in the end. So what the scientific community seeks at the moment is to convince those who are the polluters not only to espouse the polluter pays, but rather that the polluter can, in fact, be the winner and not have to foot the bill because they've learnt not to pollute. So those who will actually opt for sustainable solutions, and I'm looking to you in order to answer your question, if you have sustainable solutions for a sustainable planet, which is more profitable, closer to man, and more long-lasting. So you're asking for innovation here because it's a completely change of paradigm. Yes, indeed, and circular economy is one such example. Even for the clothing industry and for apparel and the whole fashion business. But this is a component, or a composite rather, of thousands of such activities, spanning the supermarkets, where you buy fast food. That's our day-to-day life. Yes, it is part of our day-to-day life. We have to all start pondering, and with respect to what Mrs. Ann said, with respect to the young girl, I think it would be very good for this girl to speak with the other kids in the club that they should start sorting. So glass should go to the bin for glass, paper for the appropriate bin, and so on and so forth. We've been discussing that for years, but children have started showing interest. I mean, where were we? I was at school and we tried. And when you were at school, the answers to the Gallups was 4% of interest for the environment. So the politicians went on the basis of who was interested in the environment. Okay, let's not go there. You're right, I don't disagree, but something is wrong here. Something between political leadership and scientists did not communicate. I'm not saying that the scientists are at fault, but there was a gap, if you like. Somebody didn't hear somebody else. Yes, we see that this was, in fact, dependent on oil or on coal. So, Mr. Zan, let's come to the third point of the report, which has to do with adjustment. Let's dwell on that. Let's look at mitigation and adjustment, or shall we leave mitigation for later? You'll explain why both are needed. Well, adjustment is very much needed because you are building the defence in order to tackle the phenomena to come. So that means that there's an open small window, because if we're talking about adjustment, there's a field for adjustment that permits us to adjust, that is. Yes, indeed, there is such a field. I think we've talked about adjustment and circular economy, but I think that adjustment means something different in each sector of the economy. It's something else for farming, it's something else when we're talking about natural disasters, and something else when we're talking about tourism. So you're building, in fact, a system to actually tackle the oncoming phenomena. You're not resolving the root cause. And it is mitigation that comes into play here. I think adjustment is needed, but mitigation is key, because in actual fact it changes the entire philosophy, the philosophy that we have with respect to the future in the 21st century. And what do I mean by mitigation? We have said and we've understood that the greenhouse gas emissions, CO2 and others, well, these are very harmful. They increase the temperature of our planet and have manifold fallout. And the IPCC comes and says that on the basis of the data that we have and the forecasts that we make, that the target of 1.5 degrees centigrade, which has been set in the Paris Agreement, will be exceeded. This is the average forecast. In the first years of the 2030s, this is quite near and not that far away. So what about the rest of the CO2 that we could emit in order to reach the target of 1.5 degrees centigrade? So the more that we delay, the CO2 that could be emitted should be curtailed even more. So that for every year that goes by, we have to curb our emissions even more. This shows how urgent this action is on a global scale. Europe is a pioneer. It's far ahead from the other regions and continents, as it has put certain targets. In 2020, it had the reduction by 20%, use of alternative means of energy, plus that is RES, plus 20%, and it has targets for 2030, and it has, in fact, the climate neutrality for 2050, and it sets further targets. But Europe cannot go it alone, and it cannot address the global problem alone. We have to be realistic, and sometimes when I look at the scenarios that we examine, the various scenarios that we consider in terms of emissions in the future climate, I don't know how optimistic one can be. I'm not certain that we will actually follow the best possible scenario in order to keep the increase in temperature to 2 degrees centigrade. I think we'll be in the middle way between the very good and very poor scenarios where there's no mitigation whatsoever. That's it from me, but I'd like my interlocutors to also discuss this. But this gives us a line of inquiry. Mitigation, reduction of emissions. How are we going to go about it? That's one question, which is very serious indeed, because my fellow panelists have talked about it here. Just transition. How is this going to come to pass? And it's not just transition only in Europe, but globally. There are a lot of issues that come about and difficult dilemmas. Even within a country, you often see and hear different opinions about how we're going to get there. So a common goal, but a difficult approach thereof. In order not to be pessimistic, even the very good scenarios are still something that are in our reach if we act globally now.
Let's go to the other side of the Atlantic, and we are drawing to a close now. So please, let's go to the other side and see another type of dilemma in a very different era. We would say that this is a very courageous and grand plan for climate change through transition to clean energy. Thanasis Traboukis talked with Isas Stashwitz, senior advocate at the Climate and Clean Energy Program, which is a group that promotes the environment in the US. Let's hear what this plan is about and what is the greatest dilemma that has to be solved for a total transition.
Thank you very much for agreeing to this interview. Up until now, the international community has shown an absolute reluctance to adopt effective measures on climate change. Why is that?
Well, I think I would disagree a little bit with the premise of the question. I think the international community has actually done a lot. It absolutely must do more to meet the challenges of climate change. We know this is an existential threat to the planet, to people, to wildlife. But the Paris Agreement includes commitments from all major emitting countries to cut their climate pollution and to strengthen those commitments over time. And we saw last year China committing to reaching carbon neutrality by 2060. We saw South Korea and Japan committing to zeroing out their emissions by 2050, alongside a number of other countries. What I like to emphasize is that climate change is not like an exam where you pass or fail. We can always do better at avoiding more warming. So really, we need to celebrate the progress to date and just, keep going.
The US Congress right now is debating its most significant climate change bill ever, which will bring extraordinary changes in the country's energy sector. So what should we expect if this plan gets the necessary votes?
Yeah, thank you so much for asking about that. I'm spending a lot of my time working on that these days. And I'll just say, I came to NRDC in mid-2008, so about 13 years ago. And that was the last time we had a window of opportunity this big to do something major on climate change. So for us at NRDC, that means passing a strong budget reconciliation bill, and we are focused on 4 essential priorities. So the first is clean electricity, shifting to 100% clean sources of electricity by 2035. So this is, really the backbone of the effort. Number 2, clean transportation. In the United States, the transportation sector is now the largest source of climate pollution. And so what we saw coming out of the House, the investments in that bill, would dramatically deploy electric vehicles and also support making reliable, modern public transportation options available to more people. We also have 2 other priorities: safe drinking water. The bill would fully replace aging lead drinking water pipes across the United States. These are pipes that are poisoning children's brains, especially in low-income communities of color. It's a major environmental justice issue that we are focused on. And number 4, getting toxic pollution out of our communities. We have a legacy of, toxic pollution from the fossil fuel industry, uncapped orphaned oil wells, gas wells, and so forth. And the bill includes funding to remediate that.
What impact will it have on the industrial decarbonization, and how will it affect each sector separately?
Thank you for asking about that. So I spend about half my time working on industrial sector decarbonization. As you know, scientists are telling us that as a globe, we need to cut in half our emissions by 2030, and we need to achieve net zero emissions by mid-century if we're going to avoid the worst consequences of climate change. So put very simply, we don't hit our North Star climate goals unless we have a plan and policies in place for decarbonizing industries like cement and steel. Really critically, the path to zero emissions for these sectors, it's not through obsolescence or replacement the way that we think about fossil fuel refining, for example. The path to zero is through innovation, and we have to ensure that we have policies on the books today that incentivize investment today to deploy the advanced technologies that we know we're going to need in 2040 and 2050 to deeply decarbonize these sectors. So cleaning up these, heavy industry, it offers enormous emission reduction opportunities, but it also offers an opportunity to invest in our manufacturing sector, global competitiveness, high quality jobs. I know this is true in the United States. I'm sure it is true in other economies around the world. There's an enormous opportunity if we're going to be spending billions of dollars on infrastructure to build bridges, highways, roads, tunnels, rebuild federal buildings. All of that construction, at least some of that construction, but ideally all of that construction should be done using lower carbon materials.
Να ξαναχτίσουμε ό,τι
υπάρχει, So let's rebuild what is there, but how? We only have a few minutes left, a couple of minutes, so please, only brief questions. Yes, please. Thank you. I would like to touch upon the issue of education, because our dear professors mentioned this word often. So actually, we are talking about environmental education in schools, which is not there. Mrs. Evelpidou was telling me that as years go by and as things worse, the times dedicated to environmental education at schools are becoming less and less. Why? Look, it's something we need more than ever. Our children need to know what is happening, need to know how they have to behave. It seems that we haven't managed to do something ourselves, and at the same time they are going to live in an environment which is going to be more difficult than our environment. They have to learn how to protect themselves. We need environmental training at schools. However, the hours dedicated to this subject are becoming less and less. So it seems that obviously there is no political will. At the same time, we have many educational programs running on the initiative of the state and public bodies. There are many educators and teachers that want to assist, but they are not in the timetable. So it seems that they are not part of the curriculum. It's only 1 hour a week. That's all. And education is a wider issue, yes, but it has to start from somewhere. And this somewhere is linked to different things. Education can come from fairy tales told by parents to children. Then we have education at school, and education of professors coming from professors. That's worse. Our education Maybe we become too arrogant. We think we know everything. Climate experts are climate experts, doctors are doctors, and geologists are geologists. Nobody knows everything. So we have these mixtures of trends of knowing everything. And we have to reduce this. This happens in the Mediterranean peoples. They have the same problem in Italy, in Malta, in Alexandria. So geographically, this is where the impact of the climate change will be. And the issue of education, you very aptly raised, is a sine qua non conditio. It is the necessary tool. As regards general education, you talked about education, environmental education. There is no art education as well, and you're an architect. Is there music in schools? Is there poetry? What is there? Excuse me. All these things comprise education that will make complete human beings, which will actually do recycling after we have these recycling beings. It's also my generation, you know. We went through the financial crisis, the social crisis, refugee crisis, which is still there, and we also have the public health crisis, and we're criticized by the younger generations of climate change. No, it's my generation, says the professor. It's my generation that is to blame. Yes, but now my generation is to blame too. So we have a huge problem with the generations. Any other questions? A very brief comment. We only have a few seconds. We have to train our children. The children will train the adults. An 8-year-old knows what they have to do, and they will tell their parents off if they don't do it. My name is Omiado Georgia. I have to mention your names too. I am a theater culture expert, and actually I have a query as regards what is happening today in the coronavirus era. Could it be that climate change has an impact on diseases and health? Maybe mutations are worse or infectious diseases are worse, because the main problem created by climate change is this increase in temperature. Maybe this increase in temperature could lead to viruses and infectious diseases. Yes, there is a study. Especially in Siberia, ice melting could bring about new soils and cause old viruses to defreeze. And these viruses could be transported by birds from Siberia to China. 8 out of 10 pandemics coming from viruses come from China in the last 100 years. So something is there. This piece of work was to be reviewed by Chinese reviewers. They didn't want to review this piece of work, then they sent it to a European, and this piece of work was finally published. So actually this hypothesis is not very convenient, that if all ice melts, and if we have these old viruses becoming warm again, we will have extreme events. I just hope that nature will not hold this in store for us. This will be the worst case scenario. I would like to thank you all for today's debate. It was a very lively debate because this is a burning issue. I would like to thank you all for sending us online messages. I would like to thank Αναστάσιος Εψημίδη, Βασιλική Αράδη, Νίκολας Κάκαρης, Μαρία Τσιαντή, Πέτρος Αποστολάκης, Γεωργία Ψωμιάδου, Κωνσταντίνος Ειρηναίος Σταμούλη, Αποστολή Ακόμη, Γιάννη Σαΐτης and Δία Κοντόρη for their presence here today in our debate. It has been a very fruitful debate. We were here in person. I would obviously like to thank the panelists. Thank you very much once more for letting us have this place, the Academy of Athens, the first research institute in Athens. Mr. Zanis, thank you very much. Mrs. Velpedu, thank you for the photos, which were very, very nice, because they helped us understand directly the situation, and our debate is still open. The material of our dialogues will stay on our web page. Climate change, climate crisis, part 2. We're going to have many more parts. Warm thanks. We just wish that this window will be visible by all and fully utilized in the best possible way. And we just hope that this window will stay open. I don't want to finish in a pessimistic note, but I think that we have to keep the window open. I would like to thank you for your invitation. We could sit here for hours talking about this issue. Yes, indeed. I believe that in 1.5 hours it's impossible. It has been more than 2 hours. Yes. So one can touch upon so many issues, and indeed we could stay here till morning. On our web page you can find material and references and links with necessary information tools about climate, and this will be constantly updated. A couple of words. The etymology of the word epistemon, scientist in Greek. Epistemon comes from the verb episteme, which means to know well. So scientists know well. Of course, always based on their personal capacities, but science at large is never wrong. So please listen to what scientists have to say, especially if the majority of scientists agree. But scientists have to talk in a simpler way to the people. Yes, I would like to thank you, and I would like to thank Mr. Tromboukis as well for this discussion. Ms. Velpedu, thank you very much. I just wish that you organize this type of dialogues to bring scientific knowledge closer to the people. Thank you, thanks a lot. We will be back in October. Thank you.